Okay, so I'm going to go over a basic setup for a Viseme, and I can't stress the idea enough that a Viseme isn't just a visual phoneme. It's not some controller that just takes control of a couple of phonemes. There's actually a concept in there, which is you want to set it up so that it has these kind of opposing shapes. So let me go ahead and open up a file. It's like the one we had in class, except I moved it around and made a few triangles disappear so that we can focus on what we need to here, which is just the lips. So if we inspect this, there should be a shape which is called phoneme basic 4, and we're going to find that there's a pucker, which is a forward motion. There's a E, which is kind of like pulling the skin back on the mouth, so that those are two opposing ideas. We have an shape, which is over exaggerated here, but it's going upwards, and an ah shape, which is going downwards. So those are also two opposing shapes. So I'm going to start by creating a four-way controller. So what we do is we create a locator. All right, and I'm going to make it so that I can actually see the axis again. Now we want to make a square around this and have the little whatever we decide to use as a controller inside of it move around on this axis. So right off the bat, we know that we're dealing with an X and Z rotation or position, but we're going to rotate this so that it's X and Y. So that'll be about minus 90 here. So we're going to be moving a controller along an X and Y axis on this controller. And now we need some sort of visual to show us the extents of it. So I'm going to go create. It's going to be a NURBS primitive, so I'm going to create a square. Now the square is not going to be the right size because a square is a 1 by 1, but our dimension should be from 0 to 1 and 0 to minus 1, depending on which direction you go for an axis. For an axis control. So we need to make sure this thing is twice as big. So I'm not going to scale it. I'm just going to go into NURB square here. And I'm going to change this to 2 and 2. So now we have a shape that very accurately describes the place where the controller is going to live, and it's on an XY axis. So I'm just going to grab this controller, or this transform, which is the NURB square's root node, and then I'm going to shift select the actual locator, and I'm going to parent that by pressing P. So now if I select this locator and move it around, I should have the ability to move it into place. So let's say I'm going to, because we're doing this as an illustration, I'm just going to eyeball where I want to place it. And we're going to also be, at the same time, testing our knowledge of coordinates by manipulating this and seeing if our little controls still function correctly. So if I scale this, right, which is usually a no scaling, but in this case it's okay. We're going to use it to our advantage. If I scale this now, any object that is child of this locator will allow us to move along an axis that is no longer the scale of the world, but according to it, it will travel just between 0 and 1, and in some cases, minus 1. So that's going to make the setup much easier to do, and we're going to do a lot less work if we do something like this. So let's create like a little sphere. You can make it whatever it is that you want. I'm going to make this radius a little smaller. Something like that. So this is the thing that we're going to select, and I'm going to match it with the locator that we have there. So we bring it in. We could have done this before, but I really wanted to show the step-by-step here in this fashion, so we can see that we're just manipulating and using the knowledge that we've gathered in class. So I'm going to go to Modify, Match Transform, and I'm just going to match the translation. One of the things you're going to notice is I added some buttons. So match translation is there now, and match rotation is also there. So that's a quick button. So basically we have a little controller like that is going to be parented to the locator. Now, one of the things you're going to notice is we didn't scale this at all, and the scaling value changed. That's because when you did the parenting, it attempted to maintain its world visual size, to the parent space. So it figured out what scaling it needed to do or have in order for it to maintain what it was currently set in. So even though our scale was 1, based on our scaling here, and this is for the ride, this goes for the ride now, any scaling I do, it's always going to try to follow whatever the parent's scale is. So when you do parenting, just note that there is a bit of an adjustment that it will automatically happen. So it maintains that size we had originally. So that's a little bit of a side note, but it's important to understand our coordinate system, right? So the only thing I want to do now is make sure that I can stop it from going off of this rectangle. So all I'm going to do is go into the attribute editor. I'm going to go into the transform section. I'm going to look at limit and go to translate. And I'm going to limit the x-axis so that it's -1 to 1 because I don't want it to leave that square. Same thing with the y-axis because we made sure the y-axis and x-axis are the ones that we're going to be working on. And then over here, I'm going to limit as well, but I'm going to set it to 0 because I want it to be really flat onto that surface. So I'm just going to test it. And sure enough, I can't move it off of that little rectangle even if I try to move it on the z-axis. So we're good to go here. Like you could add a couple of like little text NURBs up here so that it has a word that tells you what it's doing, but for the sake of this exercise, I'm going to keep it simple. So what we're going to do now is we're going to open up the node editor. Usually I have a button for this, but here we go. So we have a node editor over here. I'm going to make this a tiny bit smaller so I can actually still select things. So what are we trying to do here? We're trying to control the shape with the transform of the little ball. So let's see here. One way of getting to it would be to go to phoneme basic 4, which has my shapes here, my attribute, and go select. I've actually selected the node, and I'm just going to add this to my node editor and go. I'm going to press 3 to open it up, and sure enough, there's a section for weights. So that means these are going to be what I actually control. I'm going to zoom in a little bit. Now I'm going to grab the little sphere, and that's going to be the thing that controls these values. So I'm going to add this in here. I just need the transform, pressing 3 again. And this one I don't need, so I'm getting rid of it. So all I really need is the transform from this object to somehow manage these values. And these values have to be between 0 and 1. So we're going to need a way of filtering out these values. So what we want to make sure is that our positive numbers will only affect the things that are on the positive axis, and our negative numbers will only affect the shapes that are meant to be on the negative side, and make sure that one doesn't affect the other. So we need to filter it out, and then also the negative numbers that are coming out need to be multiplied by -1 so that they're values of 0 to 1. So that's all we're going to be doing. So it's going to be really straightforward. We're going to create, I'm going to press tab here, and I'm going to go clamp. I'm going to press 3 again so I can see what's going on in there. So this value is going to be the first input. And I'm going to look over here and I'm going to say, okay, so I'm allowing a number between 0 and 1. And that's it. That's the clamp. So let's take a look at the outputs, and let's consider that one of these controls will be the x-axis and the other one will be the y-axis. So in the case of the up and down motion, so that'll be the y, don't worry that it's saying RGB. That mathematically speaking, it's still the same thing. You're dealing with components. These are shader graphs, so that's why they're in RGB. But it's something that's been very commonly used in Maya recently, where we're using basically shader graph nodes to be able to manipulate our values, which is basically what rigging is, and it avoids having to use costly things like driven keys and any other fancy controls that, or like even mel scripts and so on, that could cause a real slowdown to our rig. This is actually pretty efficient. So I'm going to grab the y-axis of this clamp, and I'm going to see if it's been isolated And I'm just going to go, okay, Y up would be the shape, right? Because that's what we wanted to see. So I'm going to minimize that. And I'm just going to pull this up. And we see that only the M shape is actually being, has been filtered out, and only that one is being affected, is affecting the face. So we've successfully just grabbed one of them. So in the case of the R, it would be off to the right. So that's our x-axis. So if it were going to the right, it would be probably something like a pucker, right? So this would pucker. And it's working. Like basically, if I move to the right, the pucker is working just fine, and it's not affecting the negative values. If I go upwards, the shape is doing what I was expecting. So now let's get the negative values in there. So one of the easiest things to do is just add a multiply, divide, and I'm going to open that up with a 3 again by pressing 3. You can also use the little hamburger symbol up here. And all I'm going to do is over here, I'm going to say, take whatever the input is and multiply it by -1 across the board. So I'm going to grab the translate, and that's going to be my input. And I can see that it turned yellow because that's being used as an input now, and I no longer have manual control. And the input 2 is the value which I want to multiply by. So now I've got I've got basically a negative version of what I originally got. So same idea. Now that I have kind of inverted the values, I want to clamp it. So I'm going to grab this guy and I'm going to press Control D and 3. So I'm going to take that output, which becomes my new input. And it still remembers that I want between 0 and 1 because we just did a duplicate of it. And in this case, I'm going to open that up. This is going in the negative. These are the negative sided values, right? So what I need to do now is for the x-axis, we were saying that it was the pucker. So in the case of the x-axis, it would be pulling backwards with an E. And the y negative axis will be doing the ah because I'm pulling downward. So let's take a look at the end result. So if I grab this, if I pull, I can pull backwards and I can push forwards. I can lift up and I can open down. So we have set up opposing ideas onto a 4-way axis. Now, the fun part here is that you can do some interesting blends with it, and this is the whole point of a Viseme. So if I go like, wow. So that motion required almost all of those shapes, and I did it in a very simple little gesture. So this, what we're saying here is, this is actually useful to us because we can control multiple shapes in a user-friendly way, and it allows us to do a couple of tricky things that would normally take a long time if we had to control them one by one. So that's the whole purpose of a Viseme, really, is to give you some sort of interface where we can blend multiple things together and make it easier to create some basic shapes. Or some basic lip sync in this case. So what you want to do is create a couple more of these so that you have a little bit more control over what you're doing. But at the end of the day, the logic behind it is very, very simple. All I'm doing is I'm clamping values so that I only take either the positive or negative values, and I'm just using a multiply to change what gets fed into that filter. And then I'm punching it into the correct shape that I'm looking for. So it couldn't be easier to set this up. And this, because of our knowledge of all the values that are going into our rig, we now understand that we can manipulate this to our advantage and it's still coherent and it won't break the rig. So we minimize the need of having to change some value relative to some distance here. So if this had been scaled, I don't know, something like 40, a scale of 40, then we would have had to divide that value by 40 to get something between 0 and 1. And we don't need to do any of that because we understand how parenting works and how that affects our coordinate system. So in a nutshell, you can create pretty quick controls for a face, and they can be very user-friendly. And that's about as simple as it can get, I think. So that's a good setup to begin with.